Welcome, everybody. Thanks for gathering around the virtual telescope. I saw this article over at space.com, and it's a question that's been out there for quite some time, and I thought I wanted just to go through it with you. Haven't written it up or anything. I'm just going to kind of ad-lib it as we go. And anyway, I'll put a link to the article so you can actually get to it in the post. So if you want to see the post, go to Easy Astronomy. I'll have the video there along with the link to this article. Anyway, you can see in this image that 3 planets orbiting the star HR 8799 were captured by the James Webb Space Telescope in 2023. They did spectral analysis, detected hydrogen sulfide in the atmosphere of HR 8799c, one of the massive planets orbiting the star, and it indicates the massive planet formed through core accretion. We'll talk about that in just a second. So astronomers have they talk about how this has pushed the upper size limit of what counts as a planet, and it's thanks to new insights into how giant worlds form. So these observations from James Webb, like I said, suggest that even extremely massive gas giants, 10 to 20 times the size of Jupiter, once thought too large to form like ordinary planets, may grow through the same basic process, shifting how scientists differentiate massive planets from brown dwarfs. So, like I said, it comes from looking closely at the HR 8799 star system. That star is very similar to our sun. It's a young version of our sun, and it's about 133 light years from Earth. And it has 4 enormous gas giants orbiting far from the parent star. Each world is between 5 to 10 times the mass of Jupiter here. And that's, of course, Jupiter's the largest planet in our solar system. So these really make these big, huge planets, okay? And they're really on the line between a giant planet and a brown dwarf. And a brown dwarf are substellar objects that fuse deuterium rather than hydrogen-like stars, earning the nickname of being failed stars. And that comes from the University of California, San Diego. So there's been this debate with astronomers whether planets this massive could form from core accretion, the slow bottom-up process in which solid material clumps together and forms a core, and then that pulls in vast amounts of gas over it, or if this was a failed star. Okay, at extreme orbital distances, material is sparse and protoplanetary disks fade quickly. Many researchers thought this mechanism simply wouldn't allow for enough time for these planets to get this massive. To test that assumption, the research team used James Webb's powerful infrared spectrographs to analyze the chemical makeup of the planet's atmospheres. So they weren't focusing on common gases like water vapor or carbon monoxide. They were looking for sulfur-bearing molecules, elements that typically begin as solid grains in a young protoplanetary disk, suggesting the planet formed through core accretion. Okay, the spectral data provided by James Webb revealed hydrogen sulfide in the atmosphere of one of the gas giants, HR 8799c. That's one of the inner gas giants for that system. And that provides strong evidence that this planet formed first by building a solid core before rapidly accreting gas. The chemical fingerprint is otherwise difficult to explain if the planet formed instead through a rapid star-like collapse of gas. The team also found that the planets were more enriched in heavy elements like carbon and oxygen, more than their nearby star, HD 8799, further supporting they formed as planets, because if they have carbon and oxygen, those are the remnants of a stellar explosion, supernova, or core collapse supernova, or even a type 1A supernova. And their star was lacking that because they hadn't gone through the process to where it was fusing into carbon and oxygen. So again, it really shows they formed a hard core and then it accreted gas onto it. So with the detection of sulfur, we're able to infer that HR 8799 planets likely formed in a similar way to Jupiter, despite being 5 to 10 times more massive. And that was really unexpected, according to Jean-Baptiste Rufio, the lead author of the study. Thought it was interesting. It's kind of they're going to probably have to do more research, more study of other systems. But if this data holds up, it can show that massive planets, 5 to 10 times the mass of Jupiter, formed very much like Jupiter, hardcore accreted gas. It wasn't the other way around. Anyway, hope you found that interesting. Thanks for joining me. We'll catch you next time.